Hello everybody, welcome to this session, Near Real-Time Data Analytics with ADF. I'm Sunil Sabat. I'm a Principal Program Manager in Azure Data Factory Product Group at Microsoft. Welcome again. So here is the agenda. We will discuss about what is Near Real-Time Data Analytics, what should be the capabilities of Near Real-Time Analytics. We will look at how Azure Data Factory, shortly we call ADF, as an enabler for near real-time analytics. We'll go through a demo where we'll be capturing the tweet feeds and persisting them into Event Hub. And from Event Hub, we'll be reading those tweets back into Synapse. Okay? So what are the key takeaways? And we'll end with the summary. Okay? So when we talk about near real-time processing, let's think about what are the different types of data processing we see every day. If you look at different kind of processing needs, you will see there are two main factors. One is business need and other is the complexity of implementing the data processing. Let's look at each of them. The first one is real time. We're all aware of it. So what are the examples? Let's look at ATM cash out. You go to an ATM machine, insert your ATM card, then you give your passcode, then you say what transaction you want to carry out, whether you want to take out cash or deposit money, whatever, right? Even checking your balance, all are possible. And you get instant decision on that, right? Your credit card, your ATM card is verified, your passcode is verified, then depending on your account status, the deposits you have, you get your transaction result. That's great. But to implement all that logic, it takes a lot of processing, you know, infrastructure in terms of streaming, ability to read from the ATM machine and then persist it to some database or some historical rules engine, then making a decision for you instantly and making you complete the transaction. So that's quite a complex implementation. If you are from banking and finance industry, you might have seen that IBM used to have a stream, still they have it. IBM Streams was, I will say, was the first technology which implemented this solution for banking and finance. Then it moved to different industries. Okay. Nowadays, we see Kafka, we see Kinesis, for Azure, we have event hubs, we have a service queue, many technologies to implement it. So depending on your real-time need, you have many ways to implement the solution. Yeah? And what I have seen is each customer has its own way of implementing a solution. There's not a general platform or general pattern. You can take it and implement your real-time integration need. Okay, so that's why I will say it's a complex category. You have to really hone on all your requirements and look at all these technologies and pick the one and implement it. Okay, it means it's a maintenance, it's a management, and it's a cost for run. Now coming to batch, which is easier. Say you want to do a monthly payroll run. What you will do? You'll go to your HR system and at the end of the month, you will run a payroll query, right? And generate a report and then you will disperse money to your employees, right? It's a pretty standard job. You have to run once a month or twice a month and generate your payroll report and issue paychecks. It's simple, right? It's because your need and your latency are well under control, and it's not a lot of complexity because you are just implementing some solution on top of your ERP, right? You're just running a query, and there is a payment processor who takes the report and generates paychecks. Very simple. Now coming to near real-time need, what is that? It is more about operational intelligence for timely decision, like to fill the shelf in a store. Look at the business side. It's like more of operational intelligence, right? Why it has become so important now, right? With popularity of mobile transactions, mobile devices, customers are using the devices to make instant purchase decisions, right? I will browse on my mobile device and then I will see if something is available in a store. I will put an order and I would like to pick up my order in say 1 or 2 hours, right? That's kind of decision I'm talking about, right? And as shown here, suppose I have a store to manage and I have a shelves and my milk in my shelf is running out. Now, as the milk goes to say count one, you can get that information putting a sensor on the milk shelf or from the your point of sale machine data. Okay, that doesn't matter. But once you know that your milk has reached to count one, you want to make it immediately a decision. Okay, what to do? You want to replenish the self store, right? Yeah. So you may not have inventory. You might be in the back of the store, or you might have to order the milk, from another warehouse. And instantly, you would like to report up to your management that in these stores at this time, milk is always running out. What to do? How can we avoid that? Say next day or next week. That's kind of operational intelligence I'm talking about. There, what you have to do is not only you have to get the real-time information, you have to add secondary information and make tactical decisions, not for the store, but for your store chain, and you have to make good decision with the milk supplier and all that, right? So because of the current business need, near real-time analytics have become very popular, right? And as I talk to customers, I see always, can we do this? Can we do that? Right? It's pretty different, from real-time streaming. I gave you a good example about that. And I also talk about a batch. It comes somewhere in between. Okay? And it is so frequent need, you cannot give customers a one tool, okay, go and figure it out. No, we need to give them a general framework which they can use to implement the near real-time analytics needs, right, in a predictable, in a manageable, and in a comprehensive manner. Okay, and this session is all about the near real-time analytics. Now let's go to next. So given some introduction to near real-time processing and comparing with the real-time processing and batch processing, let's look at the specifications in detail. Near real-time processing is when speed is important, but processing time in minutes is acceptable in lieu of seconds. That's very important. It's not instant decision, but it could be minutes or it could be for tomorrow. But you need to account that event there. Okay. Combination of data processing and complex event processing. Okay. So usually near real-time processing infrastructure has both capabilities, to capture the real-time events and also enhance with additional data processing to make the decisions good for enterprise. Complex event processing involves combining data from multiple sources, to detect the patterns. As you know, it's a very standard definition, right? And how the modern tools enable CEP, we'll discuss that. And one goal here is how to identify the opportunities in the data sets, such as sales leads as well as threats, okay, and to make some tactical decisions. I know I talked about the milk in itself in a store, but you can extend that, to a sales leads or even the security threats. Here are a few use cases I put here: processing Twitter data, processing sensor data, IT systems monitoring, financial transaction, and so many. Okay, so just going to specifications again, I reiterate. For near real-time processing, we need combination of data processing and event processing, and we need to make tactical decisions not in seconds but in minutes or hours, right? Very specific to the business need. Let's go to more into what should a solution for near real-time analytics have. Okay, what are the specifications it should have? First is latency. Latency is specific to use cases, right? Most stakeholders ask for latency in minutes, latency of dependencies, and some implementations fit certain latency better than others. Okay? So depending on the customer need, the business need, tactical need, you can and you should be able to support different kinds of latency needs. Later on in this session, you will see how can we get the Twitter data and store into Azure Event Hub real time. Then you can read it back from Azure Event Hub and to do some processing, okay, and then load the data into Synapse. Okay, and along the way to the same Synapse data warehouse, you load some additional data. Okay, and then there is a Power BI model which connects all this data and gives you very comprehensive reports. Okay, it's pretty much in real time need. Okay, um, so and you need some framework which supports that. What are the other key capabilities? Okay? Multiple data sizes and sets. Okay? With the modern near real-time data analytics, you should be able to support small data, big data, medium data, different kinds of varieties. Mutability, you should be able to mutate the incoming streams, transform them, and make it appropriate to work this stream data with other data sets to make tactical decisions. Okay, it should be able to support schema evolution. Okay, that's very important. And always, right, as you're getting streaming data or you're dealing with real-time event, there could be duplicates. Okay, and you should have a way to handle that. Um, and as you build the general infrastructure, right, you need to provide a scalable infrastructure. You should scale your capturing the events, you should be able to scale reading the events, you should be able to combine this real-time data with secondary data at scale. Every step you need scalability. Okay, um, and it's because it's near real time, you should be able to support both batch queries, we saw that because there is always a need, and streaming queries. Okay, both types. Okay, and to implement a solution, okay, for these capabilities by hand, think of what you need. Okay, and how much code you have to write, right? So the purpose of this session here is how Azure Data Factory, being a master platform, how it enables you to achieve all these capabilities, okay, just using one tool and some other tools as per your wish. Okay, and you could put all those capabilities together for the best outcome. Okay, so streaming, ingestion of data, deduplication using ETL process, and interactive analytics, those are the three big things that need to happen, right, as I say in the bottom. And also we should not forget, right, the capabilities to work with secondary data sets, do some transformations at scale with security, and then get your the combined analytics done quickly. So we need a comprehensive platform we support all these capabilities. Yeah. So this talk is about Azure Data Factory, which enables this near real-time streaming with the specific capabilities we talked about recently. Okay, uh, those you don't know, right? ADF is built on a cloud-native foundation, built with Orchestrator, part of Azure data ecosystem. It can handle petabyte scale copy, then moving the data with 100 plus connectors. And it also offers code-free data transformations for billions of records using Spark. So not only it can copy the data for you, okay, at scheduled trigger, we'll talk about that. It also allows you to transform the data at scale with Spark. And if you take those key capabilities of ADF and you look at the today's need, which is the businesses need near real-time data analytics done at a streamed event, but decisions are made in context of many other data sources. Okay, if you think about the near real-time capabilities to meet the business needs and what ADF can do, that's a good marriage. Okay, so this session is again all about that. Okay, um, also, as you can see here, ADF is a perfect tool to orchestrate data movement, real-time ingestion, and preparation with Databricks. Okay, if you want, we'll talk about that. And then loading to Synapse Data Warehouse for your Power BI analytics. Okay, look, how can we put the data warehouse like Synapse and the event streaming capabilities of Databricks, right? And then add it with data flow transformations, put all three together, right? And you can build the best near real-time solution, for your business needs. Again, coming here, right? Before we go more into demo and how we do it, let's go back and look at, right? Is streaming and this we call change data capture are new to ADF? I say no, because streaming or change data capture is not new to ADF, right? If you look at ADF's history, even in the V1 of the product, we supported Spark streaming using Azure HD Insight. It means Azure as an orchestrator can initiate a Spark streaming job for you, which is real time, micro batch based streaming need. So you could implement a real time solution using, you know, um, Azure Data Factory and Spark streaming of Azure SD Insight. And there is a URL for that. You can see that. And what are the other change data capture type solutions that are available with Azure Data Factory? As you know, for SQL Server managed instance, we have solutions based on LSN. Okay, and here is a URL which talks specifically about how you implement change data capture, right? And with ADF, right? And how can you get the updated record information, on your target data warehouse or database, right? There's a complete example of how you do that, right? Then we have SSIS. That's another integration product, from Microsoft. You might have known. SSI is a SQL Server Integration Service, and with SSIS also you can achieve change data capture. Okay, that is for the SQL Server and SQL Server managed instance and so on. Um, and Azure Data Factory has a data flow. Okay, that's a mapping data flow. With that, you can implement your slowly changing dimensions, right? SCD1, 2, and so on. You can implement all those patterns using data flow, because nowadays customers want to implement SCD1 and 2 type solutions for big data solutions, for your big data need at the easiest way possible. Data flow with its visual flow, low-code platform allows you to achieve those uh, solutions. Uh, and you can extend Azure Data Flow slowly changing dimension to Synapse Pipeline SCD also. So with Synapse Pipeline, okay, not only you can achieve your streaming solutions with Synapse Spark pools, okay, which are pretty much like your Azure SD Insight, Spark streaming. On top of that, you can implement your slowly changing dimension patterns using data flows, for the Synapse Azure Data Warehouse. There are many ways to achieve, your near real time, needs if it works out for you. Okay. There's yet another way, to implement your near real time, solutions using Azure Data Factory using existing capabilities. Okay, like as you know, we offer different kind of triggers, right? We have schedule triggers, we have tumbling window triggers, we have storage event triggers, and recently we announced custom event triggers. You can use any of above triggers to make ADF pipelines operationalize enterprise near real-time data integration. Okay? Uh, Here are a few examples, right? You can use tumbling window to implement repetitive pipelines every 5 minutes between 2 days. Okay, and it can go back to the history, given on the dates and rerun the pipelines. Okay, that's one way to do it. The second one, the new one, I will rather say, is you can use a custom event trigger to listen to an event like email and trigger pipeline. Okay, possibilities are many. Yeah? But given all these solutions that are already available with the Azure Data Factory, how can we make it better? As I told you in the beginning, the world has changed with mobile data, with mobile users. Customers are all over our businesses. They want to transact with us in near real time, and they want to know our predictable decisions from our side about their purchase, about their transactions, about their health visit, right? There itself. How can you make it better? Right. So for that, what we need to uh, showcase and implement is, massive real-time data source like Twitter. It's an example. We should support that. Ingest and process real-time feeds with Spark, because when it's real time and you have to ingest and process, you need a Spark foundation. Okay, we should be able to do that. I know I'm talking about Spark, but there are other solutions in the market. You can go for that, but this talk is all about based on Spark and the proven technologies that enterprises are adopting. Okay? Then we should add and transform related data sources again with Spark. Okay? Keep your target data warehouse updated in near real time. That's the key. If you make tactical per hour in very strict decisions, right? Your data warehouse needs to be refreshed with this real time you know feed. Okay, and how to make that happen. And along with that, we need to source different data sources also, so that we can give a comprehensive decision. Okay? So to do that, we need to have a Power BI report also attached to the data warehouse. So as your data warehouse gets updated, your Power BI model gets updated, and so also your report. Okay? So that way, what we're offering is instant decisions are made at enterprise scale, meeting our near real-time streaming definition. Okay? So let's see for this session, right? I've implemented a solution to walk you through how it is done. Uh, let's go. What is the setup? Setup is you enable Azure Databricks with Twitter APIs to read Twitter feeds. You enable Synapse Workspace with the Power BI report. Then you build an ADF pipeline with the ADB just Azure Databricks activity and data flow activity. That's a setup. Then you develop a few notebooks. So within notebooks, tweets are captured and sent in Event Hub and loaded to Synapse. Okay, all those work done inside your notebook. Okay? And as I said, right, this is not about just getting the tweets and quickly persisting event hubs and loading to Synapse. That's pretty much a given way. That's near time streaming. But for near real time analytics, we need to contextualize it with respect to secondary data sets. That's where ADF processing comes into play. Um, you can use ADF to orchestrate copy ADV activities to land real-time to Synapse. Okay, we will do it. We can do it. Then we can orchestrate data flow activities to update other Synapse tables. Required for your Power BI reports, because Power BI reports just doesn't run on your tweet data, which can do it in some occasions, but for your near real-time tactical decision making, right? We need to populate your related data sets, also. Okay? As data gets loaded into Synapse, your Power BI report is also refreshed. Okay? So what are the benefits of implementing such a solution with ADF? I've already talked about it. ADF is an orchestrator in addition to being as a copy transformation capabilities, right? It can do copy, it can do transformation, but it is orchestrator. Azure Databricks handles Twitter schema, mutation, and stream transformations if you want to do stream level transformations. Okay? Then ADF copy and data flow can load additional data sets to Synapse, for your contextual and comprehensive decision making. There's a Power BI which is attached to your Synapse, SQL pool. It's refreshed, with the new stream and built-on streaming data and additional data sets. Other near real-time analytics with ADF also possible. Okay? So those are the key benefits. ADF released a private preview of change feed connector also. So given these capabilities of ADF and you can implement a solution, we are not stopping there. We're enhancing our real-time ingestion capabilities. Recently, we have released in private preview a change feed connector for Cosmos DB and load the change data to your data warehouse of choice. There, what we are doing is we are reading the change feed from Cosmos DB using data flow, right? And then once you capture the change feed, you can run your data flow transformations and then make the decisions, okay, based on your real-time needs. Okay, um, and then you filter the curated data into your data warehouse. Okay? You can read event hub data sets into ADF, transform them with data flows, and load to Synapse. You can use a new custom event trigger to read from generic event subscriptions, trigger pipelines for real-time data loading, and conducting analytics. There are many options available. Yeah? So what is the architecture of our proposed solution before you go to demo? You can see I'm reading the Twitter API. I have a few Databricks notebooks running. I have a publisher notebook, consumer notebook, okay, and then I have a producer notebook. Okay, those three notebooks are being orchestrated by Azure Data Factory. Okay, um, and then within Azure Data Factory, I'm able to load back to Synapse. Okay, and then my Power BI report, right, is refreshed with a data set, available in Synapse. Again, with this architecture, let me repeat. I'm reading the Twitter API output inside a Azure Databricks notebook. Okay? I call them a producer notebook. Then I have a consumer notebook, which reads those tweets from Event Hub. Then I have a publisher notebook, which just writes to Synapse, and the Power BI report gets refreshed with this these tweets. Okay? And later on, I will show you within Azure Data Factory, we have data flows also already defined, which can source your secondary data sets and apply all the necessary data transformations and load to Synapse. So that way, your Power BI report, which is not only dependent on the event, but the secondary data source, enables you to get the best analytics, in real time. Now, here's another view of the diagram we saw before. You can see I can read any real-time feeds like Reddit, Quora, Spiceworks, Google, Facebook. But here the tweet is an example. Then it gets persisted in event hubs. Then I have a Databricks, within ADF, right, which basically processes it, and all running on Azure. And the Power BI also gets refreshed, because of Azure, because of the ADF's orchestration capabilities. And you will see that it's not only Databricks that refreshes the Synapse tables. Here we have a data flow, which also enhances, the data sets, for Power BI reports. So here you see ADF pipeline. You can see that's being how it is orchestrated. I have a validation activity. Then I have a copy data. And once the copy data makes the file ready, I am reading the tweets, right, with a notebook. Then I'm processing these tweets. Okay. Then I am writing those tweets to the Synapse. Okay. And once that is done, I'm also running a data flow activity, which does a bunch of other transformations and prepares other tables. Okay. Again, let me go through this pipeline again. So I have a validation activity which checks for a file availability. And once the file is ready, the file gets copied, to another blob. Okay. Once that activity is done, I run two activities. Okay? Notebook activities, one for reading the tweets in a continuous way. Then I process these tweets in the continuous way. The way it happens is while reading, I write to Event Hub, and in process tweets, I just read it back from Event Hub. I'll show you the example. So if you look at this, right, inside the process tweets, right, after the process tweets, I do a code tree transformation, and here is a data flow, which basically shows here's an example I have given, but you can add any transformation, right? We have selects, columns, we have derived columns. Here I'm keeping few examples here, but you can add any transformation and load prepared data to Synapse table. So here is a producer notebook example. You can see here are my Twitter keys. Okay, then with this I'm able to read from my Twitter account. I can search on whatever I want. Here is an example called Azure Storage, right? And with this I'm able to read Twitter data. Okay, now once I read Twitter data, I need to read it from Events Hub, all my tweets. So this is where you can see, right? I'm reading stream here, so I'm reading from Event Hubs, and then this is the way I'm using Apache Spark SQL types. I'm converted to SQL types here, and then I'm I'm still converting them to some format, right? A string format here, all those tweet feeds, and I make a string type out of it, and then I write it back to Synapse. Okay, so how I write to Synapse using my Databricks notebook, here is an example, right? I can set my blob storage names, right? And then this is my SQL data warehouse. Here is my URL and which table I want to write. I define a temp dir, and then I can overwrite or append or whatever I want. Then I do save. So here is my example. You can see here. I'm writing to SQL DW from my stream, right? Given all this information. Okay? And here you will see as the data gets loaded to Synapse, right? And there is already a Power BI, defined, right? And report. So as the data gets loaded into Power BI related data sets, on top of that, within Synapse, right, I can have other data flows. You can see here source, filter, aggregates, right, to do more data preparation, data quality check, all with data flow, right, visually, and then get the best report out here. Okay, so given all this uh, steps, what I have taken to build this near real-time Power BI report, right? From Synapse, which is being fed, not only with the tweet data, but also with enhanced Synapse and ADF data flows. Now, with this, let's see how it is being done. Okay, so here is my let's go to my how my web pipeline looks. So I click here. I don't know why it is slow today, but let's wait. So, so here I will show you while Azure Data Factory is loading. Let me see how can you quickly, build a Synapse pipeline. Here is a Synapse pipeline. You can develop, Synapse pipelines here, right? So you can look at here, data flow to pipeline to Synapse pipeline here. You can create. Let's click here. So here you will see, within Synapse pipeline, I can add, any source, put filters and aggregates and write to the Synapse. Okay. Now that's the way, how can I add, data flows within Synapse pipeline and prepare my Synapse tables to be included, in my Power BI reports. But the key is Power BI here, right? So let's go to my develop here. Now you can see, already, I have connected, okay, my Power BI, workspace, okay, to, and these are the Power BI data sets, I have. Okay. So here, go to the Power BI, right? I can create a new Power BI report. Okay. Let's look at here.